Hello, welcome to our talk on our paper, Seeing Implicit Neural Representations as Fourier Series. This is a joint work by me, Nuri H Benbarka, Timon Höfer, Moqeet Riaz, and Andreas Zell. So let's start with what are implicit neural representations and why are we talking about them. Implicit neural representations use multi-layer perceptrons to represent signals such as images, sound, occupancy, radiance fields, etc. And they represent them by mapping the input coordinate of a signal to its value. For example, here we have a multi-layer perceptron that takes in the x, y coordinates of an image and outputs the RGB value at the corresponding location. Recently, implicit neural representations became popular because of their advantages, such as being resolution-free, differentiable, and simply giving better performance when used in many tasks. In our work, we want to connect the implicit neural representation with Fourier series so that we'll have a better understanding of them and to benefit from Fourier series properties. In our work, we introduce an integer mapping and prove that the perceptron with this mapping is equivalent to a Fourier series, where the weights of the perceptron are the Fourier series coefficients and its output is a periodic signal. We also set a theoretical upper bound for the number of parameters in the embedding to get a perfect reconstruction. To verify our mathematical analysis, we use the image regression task and we simply set the weights of the perceptron with the Fourier coefficients. And we got the ground truth at iteration 0. Furthermore, we made another experiment to compare different mappings. So here, SIREN, positional encoding, integer mapping, and Gaussian at different number of parameters or frequencies. 8, 16, 128. At a low number of parameters, SIREN gets the best reconstruction because it has trainable frequencies. However, with increased number of parameters in the embedding, SIREN does not improve. However, integer mapping and the Gaussian get better results. However, when we reach Nyquist frequency, which is 128 in this case, we get a perfect reconstruction, which can't be achieved by the Gaussian because it depends on sampling. Now that we saw that integer mapping gives superior performance in the perceptron case, we see if this generalizes to the multi-layer perceptron setup. So we made experiments on the image regression task again and the novel view synthesis. We found out that the main contributor in the multi-layer perceptron setup is the number of embedding parameters and the standard deviation of the embedding parameters values instead of the positions of the frequency itself. We also found an interesting property, which is the integer mapping forces periodicity of the multi-layer perceptron. So here in this example, we see that when we force the network to output the second period, we see that in the SIREN case and in the Gauss case, the second period is not the image itself, while the integer mapping produced the image itself, which proves periodicity of the multi-layer perceptron. In the end, I want to thank you for listening and any questions.